Hello guys, here we go with one more video. Quick lesson on direct variation, chapter 8, lesson 5. Still talking about graphing lines. These are special types of graphs, special types of lines. So what I want you to be able to do at the end of today is recognize direct variation by graphing and checking for constant ratios. So you're going to recognize direct variation by graphing tables of data. I'm going to give you a couple of other ways to recognize direct variation. But first, what is direct variation? And then this is another key vocab word, constant of proportionality. Huge word, but notice right there, there's the word proportion. It's coming back to haunt you. Ha 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 ha. So we're going to use proportions again. So this is what a direct variation is. It's basically a linear function or a line equation that can be written as y equals mx. Sometimes they use this letter k for constant, kx, but notice there's no intercept because the y-intercept is 0. So m has to be a non-zero constant, and it is called the constant of variation. It doesn't change. So let's look at a couple graphs or a couple situations, and there are two ways to figure out if an equation or a function is in direct variation. One is you look at the graph and you ask yourself, does it pass through the origin? Another way is to look at the equation and you ask yourself, can it be written in the y equals mx or y equals kx with the y-intercept, the plus b over here is 0, so it's not included. And there's a third way called using proportionality or using proportions, and we'll do that also. But let's first just look at these two ways. Here's a graph. Does it pass through the origin? Yeah, there's the origin right there. So it does pass. So this is a direct variation graph. And then we look at these graphs. There's two graphs here. Neither of them, the green one nor the red one, pass through the origin. So these are not in direct variation. Okay, so let's say we looked at the equations of these graphs. Well, this graph would be y equals 5x, where 5 is the slope or the constant of variation, because if you take x, 100, multiply it by 5, you get y, 500. X, 200, multiply it by 5, you get 1,000. So this is a direct variation graph. Notice there is no plus b there, because it goes through the y-intercept of 0. Now let's look at these graphs. Here's the equations written in standard form, but we can write them in slope-intercept form if we wanted them. So the green one would be y equals negative 1/2 x. That has the mx part, but it also has this y-intercept. It crosses the y-axis at negative 1 1/2. Negative 1 1/2. Okay? Sorry about that. And then the red line is y equals 2x minus 7 if I change this into slope-intercept form, where the y-intercept is negative 7 down here, and the slope is up 2 over 1, up 2 over 1. Alright? So that's two ways to figure out if a function is direct variation. Look at the graph or look at the equation. Alright? So so this is just a tip. The constant of variation is also called the constant of proportionality. Okay? We've been using slope, rate of change. All of those are the same thing. We just like to call it 500 different things in math to confuse people, but they all refer to the same thing, okay? So there's one last way to figure out if there is direct variation, if a function's in direct variation. And here is a table of values where we have ounces, cups. This is the relationship between ounces and cups. Okay? Remember, we could plot it on a graph. And if I were to continue this line down, it would go through the origin. So it is in direct variation. That is one way to figure it out. I could write the equation. The last way is to set up ratios. 8 over 1 16 over 2. I'm taking these and writing them as ratios, and I want to see if they're proportional. To do that, remember, I multiply up and over. Okay, so I do 1 times 16, and that is 16. I do 8 times 2, that is 16. If these are equal, they're proportional, and it is direct variation. If they're not equal, it is not direct variation. Since these are proportional, it is direct variation. Okay, so that's the third way to figure out if a function or a table of values is in direct variation. And lastly, we have this. We want to now find the equation of direct variation. Given that y varies directly with x, we know it's a direct variation equation, but we don't know what the equation is. But we know it has to be y equals mx, or remember y equals kx, same, because that is the direct variation equation. Here it says y is 54. So where y is, I'm going to put a 54. X is 6. But I don't know what m is. So all I have to do is solve this equation for m. That is m times 6. The opposite is divide. I divide both sides by 6. Now I have m equals 9. So I plug it back into this equation here, y equals mx, and I have y equals 9x. Here is my equation of direct variation. Alright? Where I know what y is and I know what x is. When I know a point, I can come up with a direct variation equation pretty easily. And that's about it for direct variation, guys. It's just when the line passes through the origin or the start value is 0. I'm going to skip ahead here. So I just want to show you the proportionality thing one more time, because this is a little bit harder. So I want to know if this is a direct variation. I'm going to write a ratio. 3 over 22. I'm going to set it equal to this next one and see if they're in direct variation. Alright? Or see if they're proportional. Do they equal each other? Well, I can look right here. 3 times 2 is 6. 22 times 2 is 44. Not 24. They're not. But I could also go up, multiply across. 6 times 22, 122 plus 12 is 132. 3 times 24. 3 times 20 is 60, plus 12 is 72. They don't equal each other, which means it is not direct variation. Okay? Not direct variation. What if I graph this? What would it look like? Well, it would look something like this. So here's the graph. Sorry, I made a little mistake. If I look at this, first of all, it's not even a line. It's not a straight line. It has this point over here, and it definitely doesn't go through the origin, so it's not direct variation. All right, and then I could use the we did the proportionality right there. We did the line there. We could try to write it as an equation, but I'm not going to do that because that would take too much of your time, and I'm over my limit. So hopefully you learned a little bit about direct variation. Right there, y equals mx. It has a constant of variation. It is, you can look at a graph, you can look at equation, or you can look for proportionality. That's the third way. So much fun. Math is amazing. Graphing is wonderful. Proportionality. We love it. Hopefully that helped. And I will talk to you or see you soon.